In this video, we will discuss about the threshold logic gate. Simply, this is denoted as T gate. T gate. So, generally, to design complex switching function, we require more number of conventional logic gates. So conventional logic gates are simply nothing but AND gate, OR gate, NAND, NOR, etc. Right? So but by using threshold logic gate, by using few number of threshold logic gate, we can realize same complex switching function, right? So generally complex switching function requires more number of conventional logic gates, but the same complex switching function can be realized by using few number of threshold gates. That is the main advantage of a threshold logic gate. So threshold logic, here we are going to discuss about introduction to threshold logic gate, analysis of threshold logic gate, designing of logic gates using threshold gate, right? So first we will discuss about introduction to threshold logic gate. This is the symbol of a threshold logic gate. So once observe the symbol of a threshold logic gate, the threshold logic gate consists of n number of inputs. Let inputs are x1, x2, x3 and so on, xn. Every input having weight. Every input, let x1 having the weight w1, x2 having the weight w2 and so on, every input having the weights, right? At output n, threshold value mentioned, only one output is present. When the output equal to 1, if equal to 1, if weighted sum means input x1 with weight w1 plus input x2, what its corresponding weight, w2 and so on. All weighted sums you have to consider, that is xn, wn. If these weighted sum greater than or equal to given threshold, then the f equal to 1. Otherwise, that means weighted sum less than threshold, f equal to 0. That is the logic involved in threshold gate. Simply, every input having the weight. Multiple inputs, every input having the weight. So you have to calculate weighted sum. That weighted sum compared with given threshold value. If the weighted sum greater than or equal to threshold, output equal to 1. Otherwise, output equal to 0. That is the logic behind again a threshold gate. Very simple. Now we are going to discuss about analysis of threshold logic gate. So analysis, simple threshold gate, 2 input threshold gate we are considered. Observe this example. It is having the 2 inputs A, B. A having the weight 2, B having the weight 2. What is the threshold value given? Threshold value given as 3. When the Y providing the 1, if weighted sum, what is the weighted sum? A into 2 plus B into 2 greater than or equal to 3, then Y equal to 1. Else, that is less than 3, Y equal to 0, right? A, B are the binary inputs, so we can easily start out what are the possible combinations of inputs 0, 0, 0, 1, 1, 0, 1, 1. For every input combination, we are calculating the weighted sum, right? A having the weight 2, B having the weight 2. 0 into 2 plus 0 into 2. We got the 0. Now 0 into 2 plus 1 into 2. So we got the 2. 1 into 2 plus 0 into 2. Weighted sum we are calculating. That is 2. Next, 1 into 2 plus 1 into 2. We are having the 4. Now these obtained weighted sums compared with given threshold value. What is the given threshold value? Given threshold value is 3. So these obtained value greater than or equal to 3, then output equal to 1, otherwise output equal to 0. So these weighted sums 0, 2 and 2 less than threshold, that is less than 3, 0 less than 3, 2 less than 3, 2 less than 3, hence output equal to 0. But 4 greater than 3, so output equal to 1. So what is the logic behind in this threshold logic gate? When the output y equal to 1, when a equal to b equal to 1, then the output equal to 1, right? This is the way to analyze given threshold logic gate. So very simple, right? Threshold gate having the multiple inputs, every input having the weights. At the end of the output, threshold value given. Just at every input combination, you have to calculate weighted sum that is compared with threshold. If the obtained value greater than or equal to threshold, output equal to 1. Otherwise, output equal to 0. Right? Consider one more example. This is the one more example. There is a threshold gate having the 3 inputs x, y, z, having the weights x having the weight -1, y having the weight 2, z having the weight 1, right? So 3 inputs, all possible binary combinations you have to list it out, 0, 0, 0, 0, 0, 1 and so on, all ones. For every input combination you have to find the weighted sum. How can you find the weighted sum? 0 into -1 plus 0 into 2 plus 0 into 1. The obtained value is 0. Similarly, for this combination, obtained value is 1, that is 0 into -1, 0 into 2, 1 into 1, 0 into -1, 1 into 2, 0 into 1. So like that, for every input combination you have to find weighted sum. Then after finding the all weighted sums, you have to compare the weighted sums with, these are the weighted sums, compared with given threshold value. What is the threshold value given here? Threshold value given as 1, right? These obtained weighted sums compared with 1. 0 less than 1, hence output is 0. 1 greater than or equal to 1, so hence output equal to 1. 2 greater than 1, so output is 1. 3 greater than 1, output is 1. The obtained value -1 for this combination. -1 less than 1, so output is 0. 0 less than 1, output is 0. 1 equal to 1, output is 1. 2 greater than 1, output equal to 1. So simply either equal or greater than, output equal to 1. Otherwise output equal to 0. This is the way to analyzing the given threshold gates. So for this some small extension, sometimes in exam, right, how many number of conventional logic gates are required to realize these threshold logic, right? How many conventional logic gates are required to design the logic behind in threshold, right? So these are the input combination, this is the output, right? For which input combination output equal to 1? Minterm 1, minterm 2, minterm 3, minterm 6, minterm 7. For this combination only, output equal to 1. So you have to find the CSO expression. What is the CSO expression? Output f function of xyz equal to sum of minterms of 1, 2, 3, 6, 7, right? So first you have to find the CSO expression. Once after finding the CSO expression, just minimize by using 3 variable K-map, right? So what are the minterms are given? 1, 2, 3, 6, 7. Fill the corresponding cells with logic 1, remaining cells are filled with 0, right? Then grouping. One pair is possible, for that expression is x bar z. One quad is possible, for this expression is y. So f equal to y plus x bar z. How many gates are required? X bar z. How can you get the x bar z? We require the NOT gate to get x bar. and we require the z, x bar z in product form. So here x bar z is available, that is connected with one OR gate. For this OR gate, what is the input? Y is the input. So this is the F, right? So for single threshold logic, how many conventional logic gates are there? One NOT gate, 2, 3. So 3 conventional logic gates are present. So this entire conventional circuit designed are represented with the help of single threshold gate, right? So that is the one advantage. So take one more example. 4 input switching function. Whatever it may be the size of a threshold gate, the procedure is same. 4 inputs, their weights. This is the threshold value 4, right? A having the weight 2, 3, 1, 1. Weighted sum you have to calculate. That means A into 2, B into 3, C into 1, D into 1. Summation of all weighted sums. 4 inputs are there, right? All combinations you have to list out. 0, 0, 0, 0 to all ones. Right. For every combination you have to find the weighted sum. Weighted sums are calculated. These weighted sum compared with threshold value. What is the threshold value? Threshold value is 4 given. So obtained value 0 less than 4. So hence output is 0. 1 less than 4, output is 0. 1 less than 4, output is 0. The obtained value 2 less than 4, output is 0. 3 less than 4, 0. 4 equal to 4, 1. 4 equal to 4, 1. 5 greater than 4, 1. Equal or greater than, output is 1. Otherwise output equal to 0. So we can easily find the F. This is the way to find the F. After finding the F, we can able to find the CSO expression, for which min terms F equal to 1. So what are the min terms? Min term 5, min term 6, min term 7, min term 11, 12, 13, 14, 15. These are the min terms, right? So if the question extended to find how many conventional logic gates are required to design the same threshold logic means, after finding the CSOP, get the simplified expression. Here 4 inputs are there, so you have to use the 4 variable K-map. CSOP expression is known, then you have to fill the all ones, cells with ones. Then the CSOP expression is simplified expression F equal to AB plus BD plus BC plus ACD. How many AND gates are required? AB, BD, BC, ACD required. So 3 or 4 AND gates, 1 OR gate, right? To get the AB, 1 AND gate. To get the BD, 1 AND gate. To get the BC, 1 AND gate. To get the ACD, 1 AND gate. All AND gates are connected to 1 OR gate, right? So here total how many conventional gates are there? 5 conventional gates are present. That means 4 AND gates, 1 OR gate. This entire circuit can be replaced with a single T gate, right? This is the way to design. This is the way to design threshold logic. So one more example we are consider. In this threshold logic gate, 2 gates are given, 2 threshold gates are given. For 2 threshold gates, A and B are the inputs. And for this threshold logic gate, output of the first gate considered as a input. So let output of the first threshold gate as a X. First evaluate the first one. AB with weights -1, -1. So different all combinations you have to list out 0, 0, 0, 1, 1, 0, 1, 1. Weighted sum you have to calculate. That weighted sum compared with threshold of a first T gate, that is T as 0, obtained value compared with 0 if equal 1, greater than 1, less than 0. 0 equal 0, 1, minus 1, less than 0, less than 0, minus 1, less than 0, so 0, minus 1, less than 0, 0, minus 2, less than 0, 0, right? So what is the output of the first logic, threshold logic? X equal to A bar B bar, only one minterm, right? Which minterm? A bar B bar only, X equal to 1. So for this we have derived the one Boolean expression. This is considered as an input for second T gate, right? So again we are evaluating the second T gate by considering X as an input. So we are listing that X as a one input, A, B are the inputs. So X value either 0 or 1. So all combinations are listed out here, 0, 0, 0, 0, 0, 1, 0, 1, 0, like that. So X weight is 2, A weight is 1, B weight is 1 for second T gate, right? Then condition calculated, condition compared with 2, right? So if that is less than 2, output is 0, equal to, output is 1, greater than 2, output is also 1. We are finding the CSOP expression. What is the CSOP expression? Sum of minterms of, for which combination? Minterm 3, minterm 4, minterm 5, minterm 6, minterm 7. For these all combinations, output Y equal to 1. Then we are minimizing 3, 4, 5, 6, 7, minimize. What is the simplified expression? X plus AB. What is the X actually? X is not a external input. X is the output of, X is the output of first T gate. What is the Boolean expression for X? X equal to A bar B bar. That is substituted on Y. What is the Y? Y equal to X, that is A bar B bar plus AB. So this is simply nothing but A exclusive NOR B. So what is the logic behind in given threshold logic gate means? So here, what is the logic present? A exclusive NOR B. So this is the some important question in end examination. Then another one, this is also one question. This is also very simple, but extension given. You have to realize the obtained Boolean logic by using AOI. Determine the function f x1, x2, x3, x4 realized by the network as shown below and simplify using K-map and implement using AOI. Right, 4 inputs are given, x1, x2, x3, x4, 4 inputs are given, and their weights. What are the weights? 1, 1, minus 3 and 2. Weighted sum calculated here and compared with threshold value, right? So then based on this we can calculate f when the f equal to 1 based on these conditions. So you can easily understand. So slowly once observe, and then you can understand. Just weighted sum you have to calculate. This is the weighted sum. That weighted sum compared with 1 by 2. If less than 1 by 2, output is 0. Greater than or equal to 1 by 2, output equal to 1. Otherwise output equal to 0. Like this, you have to prepare a table. After preparing the table, you have to express f in terms of inputs x1, x2, x3, x4 in the form of CSOP. For which minterms f equal to 1? Minterm 1, minterm 4, minterm 5, 8, minterm 8, minterm 9, 12, 13, 15, right? So for which minterms f equal to 1? Minterm 1, minterm 4, 5, 8, 9, 12, 13, 14. So this is the f. Here question is, you have to realize obtained expression in the form of AOI. AOI means you have to group the zeros. Then we can get the F bar. All of you try to remember, AOI realization means and or inverted realization. For this realization, you have to group the zeros so we can get the F bar, right? You have to draw the K map, obtained minterms filled with 1, remaining minterms filled with 0, remaining cells filled with 0. Then you have to group the zeros, then you can get the expression for F bar. But we have to get the F. So how can you get the F? F bar whole bar. So this is the F bar whole bar. F bar whole bar. So all individual terms are product terms. So the all products can be realized by using AND gates. All are in which notation again? All are in which notation? All are in which logic again? OR logic, right? Individual terms are products, hence realized by using AND gates. All individual products are in summation, so we require the OR gate, then followed by the NOT gate. So this is the form of the switching function required for realizing the AOI, right? So this is the circuit. AND gates, OR gate followed by the inverter. This is the form we require. Don't expand. If you are consider this OR AND, this is not required. What is the given question? AOI. AOI means individual terms are in AND form connected with OR followed by NOT, right? So now this is about analysis of threshold gate. Now we are going to design simple logic gates by using threshold gate, right? So first for this NOT gate, first we are consider. For the NOT gate, what is the truth table? One input, one output. As we know that, what is the equivalent of a threshold gate? Threshold gate having one input, threshold gate having one input, let input is A, one output, let output is F. Threshold value, weight of the input, right? For this logic, you have to design this threshold value. So what we have to design? That means you have to find the W value and you have to find the T value. So what is the condition? Weighted sum greater than or equal to threshold F equal to 1. Otherwise, F equal to 0. This is for F equal to 1. This is for F equal to 0. Right? So we know the truth table of a NOT gate. A, F are the inputs. A is the input, F is the output. For 0, output is 1. For input 1, output is 0. Let W is the weight for A. So what is the condition? W into 0. Only one input, one output, right? When this output equal to 1, W. What is the condition? W into 0 is 0. Obtained condition is 0, right? Here obtained condition is W. But output equal to 0, output equal to 1 means these obtained value greater than or equal to threshold, then the F equal to 1. This obtained weight is less than threshold, hence output equal to 0. So two conditions are derived. What are the two conditions? 0 greater than or equal to threshold, W less than threshold, right? So 0 greater than or equal to threshold means how the threshold value? So you have to select the threshold value as negative. Then only 0 greater than negative value. You have to select any one of the threshold values such a way that this condition has to satisfy. Simultaneously this condition also satisfied. So from the first condition, 0 greater than or equal to threshold. 0 greater than or equal to threshold means 0 greater than threshold means when the 0 will be greater than the particular value, that value should be negative. So the threshold value should be taken as a negative. When T is selected as a negative, how the W value should be? W value less than threshold, right? So based on this condition, we are selecting the W value as -1, threshold value as a 0. So why? Because 0 greater than or equal to T. So we can take the threshold value as a 0, W value less than T, so -1. Like that you have to select the W and T value. Not only these two values, you can select any two values that means W value as well as threshold value to satisfy these conditions. Now we are consider the AND gate. Truth table of the AND gate you have to write. AND gate having the two inputs, one output. Let the inputs are A, B, weights are W1 and W2. We are preparing the truth table 0, 0, 0, 1, 1, 0, 1, 1. Condition we are writing here 0 into W1 plus 0 into W2. So 0 we got. So we know the truth table 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. So when the F equal to 0, when the F equal to 1 in terms of threshold logic, right? When the weighted sum is less than threshold, then the output equal to 0. So that means W1 into 0, W2 into 0. What is the obtained value? 0. So 0 less than T. That's why F equal to 0. That is the meaning of condition here. Next, 0 into W1 plus 1 into W2. Output is 0. So 0 into W1 plus 1 into W2. So we got the W2. Output is 0. That's why threshold less than threshold. Similarly, W1 plus 0, W1 less than threshold. Now here W1 plus W2 greater than or equal to threshold. So these are the four conditions we have obtained. So we have to select T value, W1 value, W2 value to satisfy these four conditions simultaneously, right? So first consider 0 less than T. 0 less than T means how the T value should be? T value should be positive. That's why then only 0 less than taken T value. So how the T value should be? T value should be positive. Generally from the first condition, is T is negative preferable or is T positive preferable, right? So 0 less than T means T value should be positive. Next, W2 less than T. So you have to select the W2 such a way that less than T. W1 less than T. W1 plus W2 greater than or equal to T, right? So easily we can select, let T is 2, W1 as 1, W2 as a 1. So individual observe 0 less than 2, first condition satisfied, W taken as a 1, 1 less than 2, second one satisfied, W1 taken as a 1, 1 less than 2, third condition satisfied. What is the fourth condition? W1 plus W2 greater than or equal to T. So 1 plus 1, that is 2, 2 equal to 2, hence output equal to 1, right? So the taken values W and T satisfied. So threshold value or threshold logic for AND gate given like this: A with weight 1, B with weight 1, and then the threshold value selected as a 2, right? One thing all of you try to remember, these weights and threshold value are not standard. You have to select the weights and threshold value such a way that simultaneously these obtained four conditions has to meet, right? That condition you have to remember. Similarly, OR gate we can design 0 into W1, 0 into W2, 0. Output is 0, so that's why threshold 1. 0 into W1 plus 1 into W2, so we got the W2. Output is 1, so W2 greater than or equal to 1. W1 into 1, 0 into W, so we got the W1. Output is 1, so W1 greater than 1. Next, 1 plus 1 into W1 plus 1 into W2, so we got the W1 plus W2. For this logic, F equal to 1, hence obtained sum greater than or equal to threshold. So all four conditions written here. 0 less than threshold. 0 less than threshold means what is the threshold value? Threshold value has to positive, right? So you have to select the T as a positive. So T positive, W2 select such a way that greater than T, W1 greater than T or equal to T, no problem. By adding the W1, W2 must be greater than T. So here T taken as a 1, W2 as a 1, W1 also a 1. So three conditions satisfied. 0 less than 1, W2 equal to 1, W1 equal to 1. Threshold is selected as a 1. Then by adding W1 and W2, the greater than or equal to T. So W1 taken as a 1, W2 taken as a 1. Both are added, then we can get the 1. right? So simultaneously 4 conditions can be satisfied. Similarly, NAND gate, you can go through the material which is shared by you, right? So similarly, NOR gate, we can design the NOR gate. So first you have to find the conditions when the output equal to 1, when the output equal to 0. So obtained weighted sum. What is the weighted sum? A into W1 plus B into W2. What are the A, B values? Either 0, 0, 0, 1, 1, 0, 1. These A, B values you have to substitute in that. We can get the combination. For example, here A as W1. So 0, 0, W2, W1, W1 plus W2. After finding this condition, according to our required truth table, only for this input combination f equal to 1. What it means, this obtained condition should be greater than or equal to threshold. Then only output equal to 1. Then for remaining all combination f equal to 0 means these weighted sum should be less than threshold. Like this, easily we can find the conditions. After finding these conditions, you have to select the W1 and W2 and T such a way that all these obtained 4 conditions satisfied. 0, right? 0 greater than or equal to threshold. Equal to threshold means threshold value we may consider 0, or we may consider threshold value as a negative. You can go for either with 0 or with negative value. Then only 0 greater than, take a threshold value or equal, right? Then W2 less than threshold, W1 less than threshold, W1 plus W2 less than threshold. So threshold value negative or 0 taken. Here T taken as 0. So W2 less than T, let W2 is minus 1. W1 less than T, let W1 is minus 1. Then W1 plus W2, that is minus 1 plus minus 1, that is minus 2, less than T. So what is that? 0. So the taken values are satisfied. But here exclusive OR gate is considered. Exclusive OR gate, A, B, W1, W2. Truth table written. Weighted sums are calculated. What are the weighted sums here? Weighted sum is 0. Weighted sum is W2. Weighted sum is W1. Weighted sum is W1 plus W2. For this, what is the logic? 0. So what is the condition we can derive? Obtained weighted sum less than threshold. Then f equal to 0. Then next, W2 greater than threshold. W1 greater than or equal to threshold, right? So why? Because for these two conditions f equal to 1. Then what is the last condition? W1 plus W2. So W1 plus W2 less than threshold, right? These are the 4 conditions. So you have to select the 4 conditions such a way that 4 conditions simultaneously satisfied. 0 less than threshold means 0 less than threshold means how the threshold value should be? Threshold value should be positive, right? You have to select the threshold value positive. Then how the W2 value? W2 value greater than threshold, W1 greater than threshold. What it means? If T value taken as a positive, W1, W2 are also positive but greater than the threshold value, right? So 3 conditions we can satisfy. Then what is the last condition? W1 plus W2 less than threshold. To get this, right? Less than threshold. When the W1 and W2 individually greater than threshold, if you are adding, definitely that value is greater than threshold if W1 and W2 values are positive. Why? Because T is positive here, right? So let 0 less than T means let T taken as a 1. How the W2 value select? W2 greater than T, so W2 value can be selected as a 2. W1 greater than or equal to T, so W1 taken as a 2, right? T as a positive, so we can take the positive value. After selecting the T, you have to select the W1, W2, so we can select, no problem. But what is the 4th condition? W1 plus W2 less than T, right? That condition not satisfied. Why? Because W1 and W2 2 plus 2 4 4 less than T, 4 less than t value is 1, so 4 not less than 1. So here contradiction is taken place. We cannot able to select w1 and w2 t values such a way that the all conditions not satisfied. Hence this is the limitation of a threshold logic gate, right? So these type of functions not realized by using single t gate. Hence these functions can be dividing into 2 or more functions to avoiding the conflict in the conditions, right? So these functions are called as a not a unate, right? Unate function is function in which presence of the variable either only in complement form or non-complement form in entire expression, right? Which function is called as a unate function? Function in which presence of the variable either only in complement form or non-complement form in entire expression. What is the taken logic here? Exclusive OR. Exclusive OR. What is the Boolean equation of exclusive OR? A bar B plus a b bar. Is it unate or not unate? Once observe. What is the definition? In which presence of the variable either complement form or non-complement form in either entire expression. So here a in normal form available, a in complement form. So in entire expression not a not in single form, a in both forms, b also in both forms. That's why this is not called as a unate function. So these such a functions, non-unate functions, not able to realize it with single t gate, right? So this is the main limitation. Example, a b bar plus cd, unate because a is a normal. A is a normal in entire expression, b in complement in entire, c and d are also normal. So a b bar plus cd is a unate function. A b c d also unate function. This is also unate. This is not a unit. Why? Because b in complement form and normal form in entire expression. So not a unit. This is also not a unit. This is also not a unit. So limitation of the threshold gate is non-unit functions are not able to realize it with single threshold logic gate. So that's why non-unit gates are dividing into 2 or more unate functions. So exclusive OR gate we are having a bar b plus a b bar. This is dividing into 2 sub functions. Let f1 is a bar b, f2 equal to a b bar. So for f1 we are preparing the truth table, derive the conditions, select the w1, w2, t value such a way that 4 conditions satisfied, right? Similarly you have to take the f2, prepare a truth table. Truth table simply nothing but for a equal to 1, b equal to 0 only, f2 equal to 1. For remaining combinations f2 equal to 0. f1 equal to a bar b means a equal to 0, b equal to 1, and then f1 equal to 1. Remaining combinations f1 equal to 0, right? So f1 individually you have to realize, f2 individually you have to realize. Then these two are in OR gate, and we know the OR gate of logic, threshold logic. So just to take that symbol, individual components a bar b and a b bar connected to OR gate. So how many threshold gates are required? 3 threshold gates are required, or else we can draw like this also. With 2 threshold gates we can design. This component consider first. Threshold get off, right? Take one more 3 input threshold gate. Output of this threshold gate connected to this. This weight should be greater than of all, higher value of all weights of second threshold, right? So this is about how to analyze and design given switching functions using threshold logic gates. This is about T gate.